Hello and welcome to my third tips and tricks video on Houdini Python. Here we can see that I have the Houdini open from my previous video, and up here I have a button that I made with the same script that loads our test Python script and runs it. As we can see here, if we click this button, it'll print our print statement. Now in this video I wanted to discuss my general approach to writing my own functions for Houdini, so that when I come across something that I need to do over and over again, like create constraints or create certain control objects, I write that own function, and then I don't need to write it each time I need to do it. And I wanted to kind of discuss how I approached writing those functions. So first we're going to start with a new function, and I want to demonstrate how I would make a constraint. Since yes, you can make constraints with the shelf tools up here, but there's not an easy one line of code that you can call by default that creates constraints. So we're going to go over how Houdini does it and then how I would write it from that. So we'll just do create simple constraint. Now before we start writing this function, we kind of need to understand what we're trying to do in this function. And the way I figure that out is by doing it in Houdini first. Now the practicality of a constraint is that you can move one object, like a null. You can move one object with a different object without them being parented. This is helpful for when you're trying to move a bone or any other kind of automation and rigs. So when we move null1, we want null2 to move with it without needing them to be parented. And we can do that with our constraints shelf tool up here. And that's how we're going to figure out kind of the general steps on what we need to write in a second here. So if we just click our shelf tool up here, we can kind of follow the steps and figure out what we need to do. So we need to select an object to make a blend constraint out of. So we're trying to constrain object 2, and we need the 1 to be our target parent. As we can see here, under null2, we now have these nodes in a constraints chop network. As we can see, it's made all these things for us. It's made an object. It's made a constraint object reference to our null1. It's made a get world constraint constraint get world space, and it's even made a blend between the two as well, a constraint blend. So what we've done now is if we move null1, it moves our null2 with it, and it'll rotate as well. And that's exactly what we want. So we just need to kind of follow those steps. So what we need to do for our def create simple constraint is we need to be able to call our null1 and null2 throughout this thing. So we need to grab our nodes. So we need to have our constraint node. Rather, I'm going to call it our constrained node. And we need to have our control node. And we will be able to input these nodes into this function when we call it, kind of like if we were to have our who.node, right? We need to import a node, or better yet, a create node. We need to have a node type, like null, and a name. Those are our inputs for this function. So we need our start node, our constrained node, and our control node as inputs for this function. So to follow along with the steps that we did earlier in our example, if we had our two nulls like this, and we wanted to constrain null2 to null1, what we did from that, as we can see, all this constraint is really, is it's taking null2 and referencing null1. The constraints are actually everything that's in this chop network. Now, if we see a null node by default, there is no chop network in here. So we know that this constraint shelf tool, what it does is it creates a chop network in our node, and in that chop network, it creates a get world constraint, a constraint get world, and a constraint object reference, and it blends those two together, a constraint blend, and it creates this output. It also sets certain parameters for these nodes. As we can see, it has a reference to the space above, the level above, and we also have a reference to our null1. We also can see that under the transform, the constraints have been enabled and it's referencing that chop network. So those are the steps we need to take. So first, let's do that creation of a chop network in our constrained node. So the way that we would do that is the chop network is a node and we're creating it inside of a node. So all we need to do is just create a chop network. And I'm going to call it the chop network. We'll just call it chop network. Chop net. That works. And that will be a constrained object dot create node. We can see what this type is. It's chopnet. Chopnet. And we'll just call it what our shelf tool calls it, which is constraints. Perfect. So now, if we were to run this function and give it a node, a constraint node and a control node, all this function would do at this current time is create this chop network with nothing in it, just the chop network, and it would call it constraints. But we want to create nodes inside of here as well. So what we're going to do is we're going to create nodes inside that chop net. And we know that the chop net is a node, so we can create nodes inside of it. We need to create a constraint object node, a constraint get world space node, and a constraint blend node. So let's create those nodes. So let's comment this real quick. Create constraint nodes. That's our next step here. And our first step was create chopnet. So now we just use our chopnet variable and create more nodes within it. Let's call this before that, we want to store each one of these nodes as a variable as well, so we can call them later and set params and other things like that. So we'll call this the object reference, obj ref, create node, and this is our object constraint object, or constraint object rather. Constraint object, and we'll just call it, we can name it based off of our control node, which is what we're referencing. So we could call it our control node dot name, which will just grab the name of that node, and then we can add a little bit of a more to that string. We can call it our obj ref, like that. Now what this will do is it will create our constraint object node with the name of whatever the control node was, plus underscore objref. And now we want to create our get world space. So we'll just call that world space. Which will be another node that we have to make. So let's create another node, and it's called, this is a constraint get world space. Perfect. And I'm just going to call that get world space, as our shelf tool has done for us already. But I'm going to add underscores between each one so it's more legible. Get world space. Perfect. And now we need to make our last node here, our blend chop, constraint blend. So we'll call that our blend. Here's our chop net, that create node constraint blend. Yep, constraint blend. I'll just call that blend as well. Perfect. So now we've created in this function all of our nodes here. And I can show you this, for example, if we create a different node, def create example. And we just have no inputs for this one. And in this example, we get the obj level, who.node obj, which is this level. We need to get this node. And we create our null. We'll call this our parent null, equal to obj level dot create node null, and we'll call it parent. And then we'll create our constrained null as well. Obj level dot create node null underscore, call that constraint. And then we want to use our function from earlier to do everything up here. So let's call our function from earlier, create simple constraint, and we'll enter our constrained as our constrained node, and then we'll use our parent as our control node. Now if we save this and we run our tool from earlier, it might give us some errors, and that's where you'll want to pay attention down here in your Python shell. Or hopefully, if we've written everything correctly, oops, so it just used our print because we're calling test print right now with this shelf tool. So let's change this to be our create example. Apply and accept, and now if we run this, so we just got a global name error, who is not defined. So that's a very important note. You'll always want to make sure you import your packages that you need at the very start of your script, who being the most important one. Import who, which is the main Python Houdini module. Now if we save this, this should work just fine now. Hopefully. Oh, there it goes. It went twice because I wasn't paying attention. But if we run this, we get two nodes created in the exact same space. And in our constrained node, we see that our constraints chop network has been made. in our constraints chop network, our 3 nodes have been made. Now we have an error on our blend because there's no sources, so there's nothing to blend. But that's fine. We know that everything we've written so far has worked. So to continue our constraint method, if we reference back to, I deleted them, which is a slight mistake, but if we reference back to our previous null objects, and we constrain 2 to 1 again, we can see that our next step is setting up these parents. That seems to be the most logical next step. So if we look in our constrained objects here, we have our parent objref, which is what we got from our parent null, which is named parent, and then we added objref, so that's good. We have our get world space, so now we just need to set up our parents. Now the way that Houdini does it with their shelf tool is it uses parent first and sets that blend to be 1, and it uses the object constraint as the second input, and it also uses that input as a 1. It also changes our blends to be 2. If we go back over to our constraint setup here, we can see that there's no blends and there's no parent setup. So that's a combination of parenting and setting some params or parameters. So let's start with parenting. Set parents. So we need to take our blend and just have its input set. So let's take our blend and set its input 0 to be the world space, which we called world space. And then we can do blend.set input 1 to be our objref. Now if we save that and we run it again, just delete our non-example nodes here. We run our function again, and we go into our constraints in our chop network, we can see that the parents have been set up the way we want it to be. However, the blends are not set up yet. So now we need to set up the params for everything. As we can see here, there's no world space reference and there's no target reference either, whereas those all come included with our shelf tool so far. So we need to set those. So let's set some parameters here. Set parameters. So let's start with our blend node, which is simply going to take this blends parameter, numBlends, change it to 2, and leave both of these at 1, as we can see with our example constraints. Both of them are at 1. So let's write that. So let's take our blend node dot parameter. We need to grab our param, and we're calling the numBlends parameter. numBlends. And then we're simply just setting that to 2. Perfect. That will set this blend parameter to 2. Now let's do the get world space, the object right here. As we can see, the get world space is just set to ... which just goes up to where this null is, which is perfect. That's all we need it to be set as, and that's all we'll ever need it to be set as. So we'll do world space dot parm, and let's check what this parameter is called. It's called objpath. And we'll set that to be that ... Perfect. Now the more tricky part is we need to get a reference to our null1 here. As we can see, they go up 3 levels and then they grab our null1. So that's the exact kind of operation we want to do. There is another way we can do it as well, but it's not as stable. If you were to create an example, if you were to create an HDA out of it, it would break. And this method is we can grab the full path of an object. So if we have an example obj is equal to a who.node, and let's just grab this null1 object here. So we'll go obj, and then we'll go into our null2, into our constraints, and we'll grab our null1 object constraint here, right? Now if we use example obj.path, if we use the function .path, it will print the full path of this node. The benefit of that is it's very easy to write .path and grab the full path of the node that you're looking for. The downside of it is that, say you have an HDA, say this was in an HDA this whole time, so it'd be obj and then into your HDA, and then you'd have these things. That name of that HDA changed to be anything that it wasn't. So if there was just a 1 added to it, this was the second object of your HDA that you've created, then that path, this full path, would break. The benefit of these references to just levels is that it wouldn't matter what these upper levels are called, it would always reference it up those few levels. So we're just going to do this. It's a better way, and it's a portion that I tripped over quite a bit later on when I figured this out. So just keep an eye out for that. So we're going to take our, essentially what this is doing is it's just saying go up 3 levels and then grab the null name or the parent constraint name. So let's do that. We're going to create that path first of all. So let's call it a ref path. And it's going to be equal to a string that goes up 3 levels like that. And then it's going to add whatever the name of our control node is. So we'll use that .name parameter as well. Control node .name. Perfect. Now what this does is it creates this exact reference, but it's dynamic to be whatever the name of this control is. So for us, it'll be parent because that's what we've called it down here. Now we want to set that ref path to be part of our parameter of our obj constraint, of our obj ref dot.parm, and it's called, this is also an obj parameter, obj path parameter, and we'll set that to be ref path, like that. Now if we save this and we run our tool again, we'll see all that work that we just did, or we'll get an error and we can fix that error. Here it created our 2 nulls again. We dive in, lay out our thing so we can more easily see it. Here's our obj constraint path, and as you can see, it set the thing perfectly. It set our target perfectly the way we wanted it to. And it set our world space perfectly, and it set our blends exactly the way we want it to be. So now if we just were to like hide our other objects real quick. Oops. Let's hide those real quick. And let's change our constraint just so we can more easily see it. Let's turn it to blue, so that's a slightly different thing, blue in circles. Now if we move our parent 1, it's not quite working yet. Now the reason for that is we can see that there's this green dot under null2, but there's not under our constraint thing, our constraint null. The reason for that is we need to now enable constraints and reference our constraints, which we haven't done yet over here. But if we, there we go, we haven't done that over here. But if we were to just do that right now, say just enter our constraints like this, then this would fully work. So we're on our last step here for creating this function, which is going in and setting these last two parameters. So let's enable constraints. So this is going to be on the constrained node itself. We're now setting some parameters. So let's take our constrained node .parm. We need to enable this parameter. If we hover over it, we can see that constraints on is the parameter name. So let's do constraints on is the parameter name. And when you want to set it on, you can do this by either writing true or by having a 1 there. Either one will turn it on. I like to write true for checkboxes like this. And now we need to, once we enable this, this new parameter will pop up, this parameter called constraints path. So now we'll have to do our constrained node one more time, parameter, constraints path. And that's our parameter name, just double checking real quick. Constraints path, and we are going to set that to be constraints. Now if we save this and we delete these example nodes again real quick, and we run our tool again, our function again, we can see that that green node has popped up. Once again, I'm just going to change the visuals real quick. And it works perfectly well. Now, if we didn't want to keep changing this color and the shape every time, just so I can show an example here, then you could also set these parameters as well. As we can see here, the wireframe color is just a parameter D color R, D color G, D color B, and it's set as 0, 0, 1. So let's do that real quick here. I'm just going to set aesthetic parms. So we'll take our constrained node. Rather, this probably shouldn't be done here. You'd want to set it up not as the constraints, because you don't want to affect the constraint nodes every single time, and you don't know if you're going to have nulls in here. You'd want to do that before you enable the constraints. So let's do that here. Let's take our constrained .parm. Now, if you have a parameter that has 3 lines to it, or 2, or more than 1, you don't have to set it one at a time. You don't have to call D color R, then D color G. What you can do is you can use this parm tuple function and just call D color. And what that'll do is it'll iterate over every single one of the D colors that it can find. So it'll do R, G, and B. However, you want to make sure that you're setting all 3 at the same time. So we're going to do set 0, 0, 1. Like that. And then if we want to change our control type as well, constrained.parm, it's probably called control type. We'll set that to be, this is 0, so this is 1. We'll set that to be 1. And then just for good measures, at the end of our constraints thing and at the end of our example, create example function that creates our nulls and then enables our constraints, want, when we usually start, it all jumbles up like this. So it's a simple organization function that we can call layout the children. It's called layout children. So we're going to grab our constraints chopnet, because we're trying to lay out the things within this inside the chopnet. So we'll do chopnet dot layout children, just like this, with no inputs and whatnot. And it'll lay out everything as you just saw me do by pressing L on the keyboard. And we want to do the same over here, just by using the OBJ level. And then we'll lay out children over here too. And we can save this, delete our nodes that get created every time, and we'll use this tool one last time. As we can see here, everything got laid out nicely in the node network. Not everything was stacked all at once. Our constrained node took on the shape and color that we were looking for. And we can see that our constraint works perfectly well. And if we go inside of our constraints network, it's all laid out as well. Perfect. I hope this helps with thought process on how to create your own functions and kind of how to proceed in making different scripts and processes for Houdini and Python. If you want to see one last tips and tricks video on specific HDA parameters and creation, then please watch my next video.